Have you ever found yourself totally marveling at how smart AI seems today, but then in the very next breath wondering why it makes such bafflingly silly mistakes? Well, you are definitely in the right place. Today, we're doing a deep dive explainer to look past all the current hype. We're going to demystify the actual magic behind modern large language models, and we'll be doing that by drawing directly from the really fascinating insights of cognitive scientist Gary Marcus.
Okay, let's just acknowledge a feeling we all have. When you type a prompt into a modern AI, the text it shoots back is just so fluent, right? It's so incredibly well crafted that it creates this super powerful illusion of human-level intelligence. I mean, it really feels like there is a mind on the other side of the screen, but we have to ask ourselves a pretty fundamental question right out of the gate. Is it actually thinking, or is something entirely different happening under the hood?
Section 1. The illusion of intelligence. How massive scale creates a convincing facade.
So look, deep learning has undeniably driven some absolute breakthroughs in natural language processing. But we really need to make a critical distinction here between useful performance and genuine comprehension. Honestly, you can kind of think of these systems like incredibly well-read, highly statistical parrots. They are phenomenal at predicting the most mathematically likely next word in a sequence because of the massive data sets they've swallowed whole. But, and this is key, they fundamentally lack any genuine causal understanding of what those words actually mean in physical or social reality.
Moving on to Section 2. The reality of pattern matching, peeking behind the curtain.
Because AI relies purely on the statistical pattern matching we just talked about, it comes with some pretty severe limitations. Since it's literally just predicting the next word, it struggles heavily with multi-step logical reasoning. It relies entirely on correlation, recognizing that two things just happen to appear together a lot, rather than understanding true causation, which is the actual underlying why of how things work. And that makes these systems incredibly brittle. If you put them in a novel situation that falls outside their training data, their performance can just completely degrade. They often fail at the kind of basic, everyday common sense that a human toddler would just instantly grasp.
And that brings us to a buzzword we hear literally all the time right now, hallucination. We tend to treat hallucinations like they're just, minor bugs that developers need to patch out. But Marcus makes the case that they're a fundamental reliability problem. When an AI fabricates a historical fact or just completely makes up a fake legal citation, it's not actually lying because it doesn't even know what truth is to begin with. It's simply generating what mathematically looks like, scratch that, what mathematically sounds like a correct sentence, which reveals a complete absence of genuine, verifiable knowledge.
Section 3. Why these limits matter. The real-world stakes.
Now, why does this distinction matter for us? Well, it all comes down to the stakes of the task at hand. Statistical pattern matching is absolutely phenomenal for low-stakes work. Drafting standard emails, brainstorming creative ideas, generating boiler code. If it makes a small mistake there, the cost is super low. But high-stakes domains, things like medical diagnoses, legal analysis, or engineering safety checks, those require deep causal reasoning and absolute reliability. In those areas, treating a fundamentally unpredictable AI as an autonomous agent, rather than a tool that needs strict human oversight, is incredibly dangerous.
Let's jump into Section 4, Building Better AI Brains, Gary Marcus's proposed solutions.
So, the big question. How do we actually fix this? To resolve these deep-rooted flaws, Marcus proposes we move away from purely statistical models and shift towards something called neuro-symbolic AI. Think of this as a hybrid approach. Imagine taking the raw, incredible pattern-matching power of neural networks and combining it with symbolic reasoning systems that use explicit rules, logic, and structured world models. Instead of just predicting text, the AI could actually start to reason about physical objects, events, and relationships, which would support real planning and prediction exactly like humans do.
And the cool thing is, the AI community is already starting to adopt frameworks that sort of mirror this vision. A great example is Retrieval-Augmented Generation, or RAG for short. The way it works is pretty straightforward. Step 1, the AI receives your query. But Step 2, instead of just guessing the answer from its internal statistical weights, it actively verifies facts against an external database. Then, in Step 3, it generates a verified answer. By forcing the AI to double-check its work against a structured knowledge base, we drastically reduce those wild, unpredictable hallucinations.
Along those exact same lines, we're witnessing the rise of tool-using AI systems, which, if you think about it, makes total sense. Why force a language model to mathematically guess the answer to a complex equation based on text patterns when you can just literally teach it to use a calculator?
Giving AI access to external computational tools, search engines, and explicit planners adds this really vital layer of reliability and verification that raw, totally unsupported language models just frankly lack.
Section 5. The Great Scaling Debate. Which path leads forward? So we know where AI struggles right now, and we've seen some proposed solutions, but the scientific community is having a really fierce debate about how to actually get to the finish line. On one side, you have the scaling advocates. Their philosophy is basically, just add more. They firmly believe that if we just feed larger models more data and throw more computing power at them, they'll naturally overcome these limitations through spontaneous emergent abilities. But on the other side, architectural innovators, like Gary Marcus, argue that scaling alone won't magically solve the problem of causal reasoning. You simply cannot scale up a pattern matcher and expect to get true understanding. They believe we fundamentally need new, hybrid architectures.
Look, deep learning has achieved totally undeniable, transformative results. We absolutely cannot ignore that. But to reach that next frontier of intelligence, to build systems that are truly reliable, that genuinely understand causality, and that we can actually trust with our lives in those high-stakes situations we talked about, we likely need to integrate statistical learning with deeper, much more structured forms of reasoning. Whether scaling or these hybrid methods will ultimately win out is a completely open and for sure an incredibly exciting question right now.
As we continue to rely on and aggressively develop these incredible technologies that are literally reshaping our economy and society, I want to leave you with this final, open question to chew on. Will the future of AI require just a larger, more data-fed brain? Or are we going to need an entirely different, structurally evolved mind? Thanks so much for exploring this explainer with me today. Hopefully this helps you see the reality behind the AI we are all using every single day.